Our universe is an immense and puzzling expanse, stretching beyond the limits of human imagination. With billions of galaxies, each containing countless stars and planets, the vastness of space is both awe-inspiring and terrifying, reminding us of our tiny place in the gigantic cosmic ocean. But how do we know about its scary, never-ending, infinite structure? Well, thanks to some groundbreaking discoveries in the world of physics that enable us to see and understand our universe better. On January 8, 1942, in Oxford, England, a boy was born who showed an early fascination with the stars and the universe. At the time, nobody knew that this boy would make some novel discoveries to an extent that his work in theoretical physics stands as a testament to human perseverance and intellectual achievement. He revolutionized our understanding of black holes and the origins of the universe, bridging complex scientific concepts with popular culture. Despite being diagnosed with amyotrophic lateral sclerosis at 21, he went on to become one of the most brilliant theoretical physicists. Known for his sharp wit and remarkable resilience, he also authored the best-selling book, A Brief History of Time, making complex scientific ideas accessible to the public. Today, almost every space enthusiastic knows his name, the great Stephen Hawking. His discoveries have helped us tremendously to explore our enigmatic universe, ever-expanding frontier that continues to captivate and puzzle astronomers, physicists, and dreamers alike. From the twinkling stars that light up the night sky to the dark, empty voids that stretch across light years, the universe presents itself as both a place of serene beauty and unimaginable danger. Earth, our relatively tranquil home, represents a tiny speck of safety in an otherwise hostile cosmic sea. As we gaze into the night sky, we're often lulled by the quiet hum of distant celestial objects, unaware of the perils that lurk beyond our solar system. What lies beyond our familiar surroundings is a vast expanse filled with celestial giants, cataclysmic events, and extreme environments that could spell doom for any form of life that might venture too close. The stars and planets we observe may be dazzling in their brilliance, but they are often harbingers of deadly forces capable of tearing apart the fabric of space itself. From supernova explosions that rival the energy output of entire galaxies to rogue planets with extreme atmospheres, the universe is full of hazards that remind us of our fragile existence. In this video, we embark on a journey through 9 of the most dangerous places within, as well as beyond the boundaries of our solar system. These locations are not just places of peril, they are the embodiments of the universe's most extreme forces and processes. Each of these celestial phenomena represents a different facet of cosmic danger, whether it be the titanic forces that govern the life cycles of stars, or the strange and mysterious environments that defy the very concept of life. So what are these places? And why are they so dangerous? You're watching Space 9, unveiling the mysteries of the cosmos, your gateway to the universe. VY Canis Majoris, a colossal giant on the brink of destruction. This red hypergiant is our first destination, a class of stars that represents some of the largest and most massive stars known to science. Located approximately 3,900 light-years away from Earth, this distance places it far beyond our solar system, in the constellation Canis Major Red. These hypergiants are massive stars that have entered a late stage of their life cycle, where they burn through their nuclear fuel at an astonishing rate. These stars are characterized by their incredible size, extreme luminosity, and unstable atmospheres. Red hypergiants are also incredibly rare. Only a few dozen have been discovered in our galaxy. VY Canis Majoris, in particular, is an astounding example of this stellar class. It boasts a radius approximately 1,500 times that of our Sun. Imagine a star so massive that if it were placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, and even Jupiter. Its massiveness is coupled with an unstable nature, as its outer layers are continuously being blown off into space by powerful solar winds, forming a nebula of gas and dust surrounding the star. Despite its incredible size, VY Canis Majoris is nearing the end of its life. It has burned through its hydrogen reserves and is now fusing heavier elements like helium and carbon in its core. This fusion of heavier elements signals the star's impending demise, as it leads to increasing instability and variability in the star's luminosity. Red hypergiants like VY Canis Majoris are destined for explosive deaths. When the star can no longer sustain the fusion of heavier elements, its core will collapse under the force of gravity, resulting in a supernova. The supernova that VY Canis Majoris will eventually produce will be a cataclysmic event. Supernovae occur when massive stars undergo gravitational collapse at the end of their life cycles. The outer layers of the star are blasted into space at speeds of up to 10,000 kilometers per second, releasing a tremendous amount of energy. For a brief moment, the star's luminosity can rival that of an entire galaxy. The energy released in a supernova explosion is so immense that it can trigger the formation of new stars and planetary systems in the surrounding interstellar medium. However, supernovae also pose a significant threat to any nearby planets or stars. The explosion releases not only vast amounts of light and heat, but also dangerous radiation, including X-rays and gamma rays. These high-energy particles can strip away planetary atmospheres, irradiate entire solar systems, and even disrupt the delicate balance of ecosystems on distant worlds. When VY Canis Majoris goes supernova, the shockwave and radiation from the explosion will propagate outward, traveling across vast distances of space. Although Earth is far enough away to be safe from the immediate effects of the explosion, any nearby systems could be devastated. The energy from the supernova could ionize gases in the surrounding interstellar medium, potentially triggering the formation of new stars or creating cosmic phenomena like pulsars or black holes. After VY Canis Majoris explodes, the core of the star will likely collapse into either a neutron star or a black hole, depending on the final mass of the core. Neutron stars are incredibly dense objects that pack the mass of the Sun into a sphere just a few kilometers in diameter. They generate intense magnetic fields and emit powerful radiation in the form of X-rays and gamma rays. Black holes, on the other hand, are regions of space where gravity is so strong that nothing, not even light, can escape. The legacy of VY Canis Majoris will live on in the form of the nebula it leaves behind, as well as the new stars and planets that may eventually form from the remnants of the explosion. The death of this giant star will contribute to the ongoing cycle of stellar birth and death that drives the evolution of the universe. While the supernova of VY Canis Majoris will be a violent and destructive event, it will also be a creative one, as the energy and materials released in the explosion will give rise to new celestial bodies. WR-104, the gamma-ray burst candidate. WR-104 is part of a binary star system located approximately 8,000 light-years from Earth in the Sagittarius constellation. At the heart of this system is a Wolf-Rayet star, a rare and highly unstable type of star that is nearing the end of its life. Wolf-Rayet stars are characterized by their intense stellar winds, which blow material off the star's surface at high speeds. These winds are the result of the star's immense energy output, as it burns through its nuclear fuel at an accelerated rate. Binary star systems like WR-104 are particularly fascinating because the gravitational interactions between the two stars can lead to unique and dangerous phenomena. In the case of WR-104, the Wolf-Rayet star is paired with a companion star, which orbits in close proximity. The interactions between the two stars have created a beautiful and intricate spiral pattern of gas and dust that is being blown off into space by the stellar winds. One of the most dangerous possibilities associated with WR-104 is the potential for a gamma-ray burst, GRB. GRBs are the most powerful explosions known to science. releasing more energy in a few seconds than the Sun will emit over its entire 10 billion year lifespan. These bursts occur when massive stars collapse into black holes, releasing twin beams of gamma radiation that shoot out from the poles of the collapsing star. The danger of a gamma ray burst lies in its incredible energy and the fact that the radiation is concentrated in narrow beams. If one of these beams were to be pointed directly at Earth, it could cause catastrophic damage to the planet's atmosphere. The intense radiation would strip away the ozone layer, exposing the surface to harmful ultraviolet light from the Sun. This could lead to mass extinctions, similar to those caused by asteroid impacts or volcanic eruptions. In the case of WR104, there is a possibility that the star could produce a gamma-ray burst when it eventually collapses. While the exact orientation of the star's poles is still a subject of debate, some astronomers believe that one of the poles may be aligned in such a way that Earth could be in the path of the gamma-ray burst. If this is the case, the effects on, unfortunately, the timeline for a potential gamma-ray burst from WR104 is uncertain. The star could collapse at any time, or it could continue to burn for tens of thousands of years before its final death throes. Even if a gamma-ray burst were to occur, the odds of Earth being directly in the path of one of the beams are relatively low. However, the mere possibility of such an event serves as a reminder of the unpredictable and violent nature of the universe. For now, WR104 remains a beautiful and enigmatic object in the night sky, a swirling spiral of gas and dust that offers a glimpse into the complex and dangerous interactions between stars. But lurking beneath its beauty is the potential for one of the most destructive forces in the universe, a force that could reshape entire galaxies and pose a significant threat to any form of life that happens to be in its path. Betelgeuse, the impending supernova. Located approximately 700 light-years away from Earth in the Orion constellation, is one of the most recognizable stars in the night sky. This red supergiant is nearing the end of its life and is expected to go supernova within the next million years, a relatively short time frame in cosmic terms. Betelgeuse has captured the attention of astronomers due to its size, brightness, and variability, as well as its impending death. Betelgeuse is a red supergiant, a type of star that forms when a massive star exhausts its supply of hydrogen fuel and begins fusing heavier elements in its core. This causes the star to expand to enormous proportions, with Betelgeuse now measuring approximately 1,000 times the diameter of the Sun. Like VY Canis Majoris, Betelgeuse is losing mass at an accelerated rate, with large amounts of gas and dust being ejected into space. In recent years, Betelgeuse has exhibited strange behavior, with its brightness dimming significantly in 2019 and 2020. This dimming led to speculation that the star might be on the verge of going supernova, though it later returned to its normal brightness. While the dimming was ultimately attributed to dust clouds partially obscuring the star, it served as a reminder that Betelgeuse's time is limited. When Betelgeuse finally does explode, it will produce a supernova that will be visible from Earth even during the daytime. The explosion will release an immense amount of energy, lighting up the sky with a brilliance that could rival the full moon. However, the energy released in the explosion could also pose a threat to any nearby star systems. The radiation from the supernova could have far-reaching effects, particularly in the form of high-energy particles like X-rays and gamma rays. If a supernova were to occur close enough to Earth, the influx of radiation could strip away the planet's ozone layer, leading to an increase in harmful ultraviolet radiation from the Sun. This could disrupt ecosystems and lead to mass extinctions, similar to the events that have occurred throughout Earth's history. Fortunately, Betelgeuse is located far from Earth, which is enough to prevent any direct harm from the explosion. However, the shockwave from the supernova will compress and ionize the gas and dust in its path, potentially triggering the formation of new stars and planetary systems. PSRJ 1000 748 2446 AD, the fastest spinning pulsar. Pulsars are among the most extreme objects in the universe, and PSRJ 1748 2446 AD is no exception. Located in the globular cluster Terzan 5 within the Sagittarius constellation, is approximately 18,000 light-years away from Earth. This pulsar holds the title of the fastest spinning pulsar ever discovered. It rotates at an astounding rate of 716 times per second, a speed that defies imagination. Pulsars are a type of neutron star, the remnants of massive stars that have undergone supernova explosions. These objects are incredibly dense, with a mass greater than that of the Sun compressed into a sphere only a few kilometers in diameter. The rapid rotation generates powerful magnetic fields and intense radiation, making them some of the most dangerous objects in the universe. The extreme speed creates intense gravitational and electromagnetic forces that generate beams of radiation. These beams sweep across space like the beams of a lighthouse, and if they were to pass over a nearby planet, they could cause significant damage. The radiation from a pulsar can strip away atmospheres, fry electronics, and even pose a threat to spacecraft or future space colonies. Despite its dangers, PSRJ 1748 to 2446 AD and other pulsars are valuable objects for scientific research. They provide insight into the behavior of matter under extreme conditions, helping us understand the fundamental forces that govern the universe. However, their intense radiation and powerful magnetic fields also serve as a reminder of the hazards that exist in space. Io, Jupiter's volcanic moon. Within our own solar system lies one of the most dangerous and dynamic worlds, Io, one of Jupiter's 4 Galilean moons. Io is the most volcanically active body in the solar system, with over 400 active volcanoes spewing lava, gas, and sulfur across its surface. This intense volcanic activity is driven by the immense gravitational forces exerted on Io by Jupiter and its neighbouring moons, Europa, Ganymede, and Callisto. Io's surface is constantly being reshaped by massive volcanic eruptions, creating a landscape that is both beautiful and terrifying. Mountains taller than Mount Everest rise from its surface, while vast plains of sulfur stretch across the moon. Lava lakes bubble and churn, while plumes of gas and ash shoot kilometers into the sky. In addition to its volcanic activity, Io is bombarded by intense radiation from Jupiter's magnetosphere. This radiation is so strong that it would be lethal to any human who attempted to visit the moon without proper protection. The combination of volcanic activity and radiation makes Io one of the most inhospitable places in the solar system. Despite its dangers, Io offers scientists a unique opportunity to study volcanic activity on a scale that is unmatched anywhere else in the solar system. The moon's intense geological activity provides insight into the processes that shape planetary bodies and offers clues about the early history of the solar system. Io's violent nature serves as a reminder that even within our own solar system, there are places that defy our understanding of safety. It is a world in constant turmoil, reshaped by forces beyond our control, and one of the most dangerous places in the solar system. The Bootes Void, the cosmic desert. While many dangers in the universe come from objects like stars, planets, or pulsars, there are also regions of space where danger comes not from presence, but from absence. The Bootes Void, located in the Bootes constellation, is one of the largest known voids in the universe, stretching across 330 million light-years of nearly empty space. It is approximately 700 million light-years away from Earth. Cosmic voids like the Bootes Void are regions of the universe that are almost entirely devoid of galaxies, stars, planets, or any other matter. The Bootes Void is so vast that if you were to travel through it, you would see almost nothing for hundreds of millions of light years in any direction. The sheer emptiness of the void makes it one of the most desolate and dangerous places in the cosmos. For any form of life, the Bootes void would be an inhospitable place. There are no stars to provide light or warmth, no planets to provide a surface to live on, and no resources of any kind. Survival in such a place would be impossible. The Bootes void represents one of the greatest mysteries of the universe. Why are there regions of space that are so empty? Some scientists believe that voids like the Bootes void are the result of the large-scale structure of the universe. Galaxies tend to cluster together in filaments, leaving vast empty regions between them. The Bootes void may simply be one of the largest examples of this phenomenon. However, the exact nature of these voids is still not fully understood, and they remain a topic of ongoing research. The Bootes void is a stark reminder that the universe is not uniformly filled with matter. There are vast regions of space that are almost entirely empty, and these regions pose their own unique dangers. While the void may not be filled with deadly radiation or violent explosions, its sheer emptiness makes it one of the most hostile environments in the cosmos. The Crab Nebula, a rotating neutron star. It is one of the most intriguing and significant objects in the universe, known for its dramatic history and dangerous characteristics. Located approximately 6,500 light-years from Earth, in the constellation Taurus, the Crab Nebula is a supernova remnant resulting from a powerful stellar explosion observed in 1054 AD. Its study provides invaluable insights into the life cycle of massive stars and the extreme conditions of space. The Crab Nebula is the remnant of a supernova explosion that occurred over a millennium ago. Historical records from various cultures describe a guest star that appeared in the night sky and was visible during daylight for several weeks. This event was later identified as a supernova, a catastrophic explosion marking the end of a massive star's life. The explosion expelled the outer layers of the star into space, creating the expanding shell of the Crab Nebula. The nebula itself is a complex structure consisting of a highly energetic pulsar, an expanding cloud of gas and dust, and an intricate network of filaments. The pulsar, a rapidly rotating neutron star, is located at the center of the nebula and is the remnant core of the original star. This pulsar emits beams of electromagnetic radiation, including X-rays and gamma rays, as it spins at an astonishing rate, around 30 times per second. The pulsar at the center of the Crab Nebula is the primary source of its dangerous properties. Neutron stars, like the pulsar in the Crab Nebula, are incredibly dense, with masses comparable to that of the Sun, but compressed into a sphere with a radius of only about 10-20 kilometers. The gravitational forces are so extreme that the material is in a degenerate state, and the star's magnetic field is immensely strong. The pulsar generates a powerful wind of high-energy particles, including electrons and protons, that move outward from the star at nearly the speed of light. This wind interacts with the surrounding gas and magnetic fields, producing intense radiation across the electromagnetic spectrum, including X-rays and gamma rays. The radiation from the Crab Nebula is so energetic that it can be hazardous to any nearby objects. It emits some of the most energetic radiation found in the universe. The interaction between the pulsar wind and the nebula's material generates a broad range of electromagnetic radiation. This includes X-rays. High-energy X-ray emissions from the Crab Nebula are a result of the synchrotron radiation emitted by charged particles moving at relativistic speeds in the magnetic fields. These X-rays are detectable by space-based telescopes and reveal the high-energy processes occurring in the nebula. Gamma rays. The nebula also emits gamma rays, the highest energy form of electromagnetic radiation. These gamma rays are produced by interactions between the pulsar wind and the surrounding material, including processes such as inverse Compton scattering. Pulsar radiation. The pulsar's beams of radiation sweep through space, creating intense radiation bursts. The radiation can be lethal to any nearby celestial objects, or, in the case of human-made spacecraft, can damage electronic components and affect communications. Despite its dangers, the Crab Nebula is an invaluable object of study for astrophysicists. Its well-preserved remnant provides a unique laboratory for understanding supernova explosions, neutron stars, and the dynamics of high-energy astrophysical processes. Observations of the Crab Nebula help scientists probe the extreme conditions of space, enhancing our knowledge of stellar evolution and the fundamental physics governing the universe. In summary, the Crab Nebula is a remarkable and dangerous region of space due to the intense radiation and high-energy particles emitted by its central pulsar and expanding shell. Its study offers profound insights into the life cycle of massive stars and the extreme phenomena that shape our universe. V404 Cygni, dramatic and dangerous characteristics. It is a binary star system located approximately 7,800 light-years from Earth in the constellation Cygnus. It is renowned for its dramatic and dangerous characteristics, primarily due to its black hole component and the high-energy phenomena associated with it. This system has been a focal point of astrophysical research, providing crucial insights into the behavior of black holes and their impact on their surroundings. V404 Cygni consists of a stellar mass black hole and a companion star. The black hole in this system is a stellar mass black hole, meaning it has a mass several times greater than that of the Sun. This black hole is in a close orbit with its companion star, which is typically a main sequence star or a red giant. The gravitational pull of the black hole is strong enough to pull material from the companion star, creating a complex and dynamic environment. The material stripped from the companion star forms an accretion disk around the black hole. This disk consists of hot, glowing gas and dust spiraling inwards due to the black hole's intense gravity. As the material orbits the black hole, it is heated to extremely high temperatures through friction and gravitational interactions. The accretion disk emits a tremendous amount of energy, including X-rays and gamma rays, as the material accelerates and becomes superheated. The high temperatures and energy levels produce intense radiation that can be detected by space-based observatories. This radiation is one of the most dangerous aspects of the V404 Cygni system. This place is known for its episodic and intense X-ray flares. These flares occur when the accretion disk undergoes sudden and dramatic changes in brightness, often due to the sudden influx of material or changes in the disk structure. During such events, the system releases enormous amounts of X-rays, which can be hazardous to nearby objects and space missions. One of the most notable outbursts from V404 Cygni occurred in 1989, when the system experienced a major outburst of X-rays that lasted for several months. This event was observed by multiple X-ray telescopes and provided valuable data on the behavior of accretion disks and the nature of high-energy emissions from black holes. Recent observations have continued to monitor V404 Cygni's X-ray activity. These observations have revealed detailed information about the variability and intensity of the system's radiation, as well as the dynamic processes occurring in the accretion disk. In addition to X-rays, V404 Cygni also emits gamma rays, the highest energy form of electromagnetic radiation. These gamma rays are produced by interactions between the high-energy particles from the accretion disk and the surrounding space. The intense gamma ray emissions add to the system's overall danger. The study of V404 Cygni has provided critical insights into the behavior of black holes, particularly in understanding the dynamics of accretion disks and the mechanisms behind high-energy emissions. The system serves as a natural laboratory for testing theories related to black hole physics and general relativity. In summary, V404 Cygni is a highly dynamic and dangerous binary star system characterized by its stellar mass black hole and the intense high-energy emissions resulting from its accretion disk. The system's episodic X-ray flares and gamma-ray emissions make it a focal point for studying the extreme conditions around black holes. Through its violent outbursts and high-energy phenomena, V404 Cygni provides crucial insights into black hole physics, accretion processes, and the broader implications for cosmic environments and space exploration. The final stop on our journey through the most dangerous places in the universe takes us to HD 189733b, an exoplanet located about 63 light-years from Earth in the Vulpecula constellation. At first glance, HD 189733b may seem like a relatively benign place. It is a gas giant similar in size to Jupiter, and its deep blue colour gives it an appearance that is reminiscent of Earth. However, appearances can be deceiving. HD 189733b is one of the most inhospitable planets ever discovered. The planet's weather conditions are extreme, with winds reaching speeds of up to 7,000 kilometers per hour, nearly 20 times faster than the strongest hurricanes on Earth. These winds whip across the planet's surface, creating a chaotic and violent environment. But what makes HD 189733b truly dangerous is its rain. Instead of water, the planet's atmosphere contains silicate particles, which condense into tiny shards of glass when they cool. These shards are then carried by the planet's violent winds, creating a rain of molten glass that falls sideways at speeds of over 7,000 kilometers per hour. This deadly glass rain is one of the most extreme weather phenomena ever observed on an exoplanet. The conditions are so extreme that survival would be impossible for any form of life. The planet's violent weather, combined with its scorching temperatures and deadly glass rain, make it one of the most dangerous places in the universe. Despite its dangers, HD 189733b offers valuable insight into the diversity of planets that exist beyond our solar system. Studying this distant world helps scientists understand the extreme conditions that can exist on exoplanets and provides clues about the potential habitability of other worlds. The universe is a place of both incredible beauty and immense danger. From stars on the brink of destruction to planets with deadly weather conditions, the cosmos is filled with hazards that make survival impossible for any form of life. While these dangers may be far beyond our reach, they serve as a reminder of the unpredictable and volatile nature of the universe. However, the dangers of the universe also offer valuable opportunities for scientific discovery. By studying these extreme environments, we gain a deeper understanding of the forces that shape the cosmos and the processes that govern the behavior of stars, planets, and other celestial objects. As humanity continues to explore the universe, we must be mindful of the risks that lie ahead. While the universe may be a place of wonder and mystery, it is also a place where danger lurks at every corner. Nevertheless, our curiosity and desire for knowledge will continue to drive us forward, pushing the boundaries of what we know and helping us unlock the secrets of the cosmos. Let us know in the comments, and we'll see you in the next video. Until next time, thanks for watching.